Hello and welcome to our webinar on creating reusable and scalable UIs with QML. My name is Stefan Joost and I'm working as a Senior Solutions Engineer in the EMEA region. This webinar is meant to give you a brief overview of the main concepts and mechanisms that QML provides in order to create reusable and scalable UIs. During this webinar, I'll give an overview regarding the following topics. First, we are going to have a look at the Qt framework and its tooling environment, as well as the workflow and tools that will be used during this presentation. After that, we will look into the core elements and underlying principles of QML, how components in QML work, how to arrange them using positioning elements, layout items, and anchors. We will continue with using QML in a dynamic fashion, as well as an overview of the model view concept. Most of these topics will be accompanied by examples and a small project that has been created for this webinar. I will conclude the webinar with a summary and a small outlook. So let's start with our first topic, the Qt framework and its tooling environment. Qt does not only offer a framework of libraries as nuts and bolts for a software solution. The Qt software development platform focuses on enabling collaborative, iterative product development. Qt offers tooling and solutions ranging from UI composition and development tooling, namely Qt Design Studio and Qt Creator, over to testing solutions such as Squish, Coco, and the Axivian suite, as well as monitoring and managing your solutions after product rollout like Qt Insight. During this webinar, I will present the following workflow as well. I will be showing Figma, used for the design and general layout. I will then make use of the Qt Design Studio bridge to export our design, add animations in Qt Design Studio, where you are also able to test it directly on a device using boot to Qt. And after that, I will export it into a project for Qt Creator and deploy it from there using boot to Qt. So what is boot to Qt? Boot to Qt are pre-built embedded Linux images for a range of reference platforms such as IMX8, NVIDIA Jetson AGX, TI AM62 and Raspberry Pi 4, just to name a few. You can find the full list of supported hardware in our documentation online. These images include a cross-compilation toolchain for Linux and Windows hosts, and once deployed on the hardware, it enables developers as well as designers to drive fast iterations, to check their changes and general concepts early in their development stage on real hardware. If your desired hardware platform is not supported out of the box, you are able to create your own QBSP or customize an existing one, since we are using Yocto to build these images. Let us continue with our next topic, core elements and principles in QML. But before addressing this topic, I want to encourage you to look into our excellent online documentation, which provides an ample amount of examples, tutorials, overviews, and the reference documentation. We also worked on the Qt QML book that you can download or browse online. Another way to gain more insights are the examples that are shipped with our Qt Design Studio and Qt Creator installations. So don't hesitate to use these while trying to gain more experience using QML for your UI development. But now let's dive into some basic or core prerequisites with regards to QML. QML is a declarative language, meaning using QML you only describe the appearance and the behavior of the UI or the elements that it is composed of. This provides you with a clean separation of front and backend layer by design. Everything that concerns the look and behavior of your UI should be taken care of in QML, while things like loading data from a database should be done in your backend layer using Qt APIs, your own implementation, or third-party stacks. As you can see in this example on the left side, the UI is generally defined by a tree of elements. In this example, the root element is the window item with a grid layout as the only child item. The grid layout has 4 child items. In our case, those are an item, a text, an image, as well as a rectangle. All these 4 children will be positioned and taken care of by the grid layout as a parent item. In QML, there are 2 types of elements, visible and invisible. Item, or Qt Quick Item in C++, is the base type of visible or visual items such as rectangle, text, or image. There are also non-visible elements such as layouts, timers, models, states, and transitions, and many more. Items come with properties, for example, an ID stored in a string, height and width properties, x and y coordinates that define the position, and so on. In this example, you can see that items also come with a list of child items, as well as a parent property. The grid layout's parent property will point to the root item, the window, and in our case, the list of child item consists of item, text, image, and rectangle. You may also create your own custom properties, such as property real speed, which will hold a speed value as a real in a property related to an item. There is also the concept of attached properties, for example key navigation.write, which lets you define how an item behaves if the right key is pressed, or list view current item, which enables you to define a certain behavior if a specific item is highlighted in a list view. In order to identify which properties are already present, you can of course have a look in our reference documentation. The QML engine. QML files or QML code are normally loaded and interpreted just in time by the QML engine. This allows you to load and use items at any time. In order to get rid of the resulting overhead, where it may be critical, such as resource-constrained embedded systems, you can also compile your QML code ahead of time. Internally, the QML script compiler, abbreviated QML-SC, can be used to create intermediary bytecode as well as C++ code from your QML functions and expressions, given that they are well defined and behaved. This enables the QML engine to call your code directly, and in case there are functions that were not compiled to C++, use the just-in-time interpretation as a fallback mechanism. Another way to optimize your solution is the use of the QML type compiler, abbreviated QML-TC, in order to compile your QML object structure to C++ at compile time of your application. Both approaches come with the limitation that every information needs to be present at compile time. We provide a comprehensive overview of these compilers in our documentation in order to dig deeper and identify how you are able to use them to your benefit. Let's address the third topic, components. Components are usually defined in or by QML files, but as you can see in the example on the left-hand side, they can also be defined in another context, for example, another QML item. A component can be seen as a template for items that may have custom functions, signals, and slots. Additionally, as a broadly accurate guideline, try to componentize your UI elements whenever it's feasible or applicable. This allows you to reuse a component across your whole UI and prevents the introduction of boilerplate code. In this example, a component with the ID red square is created, which consists of a 10 by 10 pixel rectangle colored in red. These components, defined in a separate QML file or inside another item or context like in the example, can then be used or instantiated dynamically by other means, like a loader, repeater, or view items. We will have a look at all those elements a little bit later. In our example, two instances of a red square component are being created by using a loader where the x-coordinate of the second instance is set to 20 for an offset in order to display both rectangles side by side. But this is now starting to spiral into a lot of slides. Maybe let's have a look into the promised example from its inception in Figma to adding animations in Qt Design Studio, as well as converting it into a CMake project in order to use it in Qt Creator. Since my design skills are ranging from somewhere between negligible to non-existent, I asked my fellow technical artist Arnaud to work on a small example in preparation for this webinar. This shows that with the use of the bridge, two different design tools, and the Design Studio, non-developer roles are enabled to work productively and collaborate in a Qt ecosystem. I asked him if he can come up with a small example using Figma and Design Studio. It's a temperature gauge that shows the current temperature in orange and the target temperature in degrees Celsius in the center, as well as the name of the room. On the top, you can see a small dial knob circle that will be used to set the desired target temperature. As you can see, this design consists of different elements, for example, the target temperature text and other graphical assets. These are already contained in two different items or groups. Here it is the top gauge and the temperature background. Those two items are part of the gauge itself, and the gauge has then been placed on the main screen. After the design work and layouting has been done, we are now ready to use the Design Studio Bridge plugin for Figma. There are different possibilities for exporting an element. For example, as a component, as a child, it can be merged or skipped. You are also able to already define your elements as a custom component type or assign custom properties to that element. These definitions will be exported and produce the desired QML code. The Qt Bridge also supports the export of variants. For example, if you design a button using variants with, let's say, an enabled and a disabled state. This will be exported into equivalent QML code, and the button item with the two corresponding states as well as the related graphical assets will be created. So now let's head over to the settings. Here you can choose how your graphical assets are being exported, as PNG, JPEG or SVG, and different other options, like the export of auto layouts, the usage of anti-aliasing on your vector items, or you can determine which QML element should act as the start screen once exported to Qt Design Studio. Pressing export will result in a dialog which will ask you where to store the intermediary Qt Bridge file. Now let's head over to Qt Design Studio and create a new project and import our design. On the right hand side, you have your project view as well as your navigator view. In the components sections below, you can see all default QML items and elements such as text, images, different kind of views, positioning items, as well as animations, and many more that you can use in Design Studio out of the box. To import your design, you go to Adding Assets, select your Qt Bridge file, and everything will be included automatically. As you can see, our temperature gauge component has been added to the component selection, and all our elements have been exported either as text, image, or other QML shapes, as well as the corresponding QML code to describe the temperature gauge. In Qt Design Studio, you may use side by side. What you see is what you get editing or code editing. Each edit on one side will of course reflect on the other according to your changes. Once you select an item, you will see that in the property view on the right hand side, you are able to view and edit its properties with regards to geometry, visibility, and you can also introduce local custom properties and so on. You're also able to preview your UI or even single elements using the live preview. But for now, let's just run our project, and as you can see, this UI element is still pretty static. So let's switch to a more advanced version of the same project and have a closer look. First, let's run our example and see what has changed. I'm now able to select the temperature, and the background color changes when I set different temperatures. So this has been achieved by one of the biggest benefits that Qt Design Studio provides in order to break the glass ceiling of other designer or asset creation tools. With the help of timeline animations and setting keyframes on the corresponding item properties, our dial is now able to rotate for the selection, and the background and dot of our knob are changing their color after we attach keyframes to their fill color property. This of course can also be done by coding it in QML, but from experience this would be way more cumbersome and complex than just using visual tooling for that purpose. So now that we have a nice and already functional UI element, what comes next? In order to continue to work in Qt Creator, you can create CMake files in order to export your project and open it in Qt Creator. So now it's time to head over to Qt Creator and have a look at a more advanced stage of our temperature gauge example. In the main CPP, the main QML file gets registered with the QML application engine so it can be used and loaded. In the main QML, I'm creating a gauge, but I added the usage of the onPressed handler to it in order to resize our window and keep the same aspect ratio and therefore the correct position of every child item or element. So as you can see, everything scales just fine, but if I try to resize the window without respecting the aspect ratio, all my other relations with regards to the positioning of all child items are of course getting mangled. So now we have an impression of just one scalable item or component. But what happens if we want to organize more than just one in a structured and scalable way? Let's have a look at the mechanisms that QML provides in that regard. Positioners are container items that are used when a set of types need to be positioned in a regular pattern. Items placed in these containers are automatically positioned according to their intended use. The row positioner is used to horizontally arrange items. In the example, a row positioner is centered in a parent item called BrightSquare. It defines a spacing of 20 pixels between the included items and arranges 3 differently colored squares in a row. Additionally, the column positioner is used to arrange items vertically. Flow items are used to place items like words on a page, with rows and columns of non-overlapping items. In our example, the flow item fills the parent BrightSquare item, defines outer margins and a spacing of 20 pixels between each element. Flow items are quite similar to the next positioner item called grid. It is used to place items in a grid or table arrangement. In our example, the grid item is again centered in the parent item BrightSquare and defines a grid of 2 rows and 2 columns with a spacing of 8 pixels between each cell. So now you might ask yourself, but why are there 2 ways to arrange items, positioners and layouts? So let's have a look at that. Qt Quick layouts have the same positioning function like positioners, but in addition they are able to resize their items, align items with the attachable layout property. They are also able to set size constraints using again the attachable layout property, where you can define maximum, minimum or preferred values with regard to width and height, and of course a lot more. So all in all, layouts are the natural choice when it comes to creating resizable UIs with the ability to scale. You may use different layout items according to your needs, like grid layout, row layout, or stack layout. But I guess it's better to now have a look at how that works with our temperature gauge example. As you can see, I created an instance of a component called row layout gauge in my main QML. And with the use of the keyOnPressed handler, I'm able to change the height and width of my row layout item. When we look at the row layout gauge component, you can see that it creates a row layout with a spacing of 5 pixels and sets the layout direction to left to right. Inside the layout, 3 gauge items are being created. With the use of the attached layout property, each of them fills the height and width of their respective space and aligns along the horizontal and vertical center of said space. So let's run it. And as you can see, we got 3 instances of our gauge. You can see the correct spacing between them. And when I resize the layout by pressing up and down, each gauge will be resized accordingly. The same applies to our gauge being placed in a grid layout. Our grid layout is split up in 4 columns and 3 rows with no spacing in between each cell and a left to right layout direction, meaning that the grid will be filled beginning from the cell on the top left. I also added 9 instances of a gauge with the same attached layout properties as seen before. So let's run this again, and as you can see, everything works as intended. There's no spacing between each gauge item, and 9 gauges have been added, and each gauge will be scaled when I change the dimension of the grid layout. So now let's change the layout direction to right to left and run it again, and then you can see the grid will be filled beginning from the top right cell. Over the course of this webinar, you may have seen or heard the word anchor or margins. So let's have a quick look at both of these mechanisms. QML also provides a way to lay out items using the concept of anchors. Each item has a set of 7 invisible quote-unquote anchor lines, namely left, horizontal center, right, top, vertical center, and bottom, with the addition of the baseline anchor, which describes the imaginary line on which text would sit. For items without these text items, it resolves to the top anchor. In these examples, taken from our documentation, we can see how they work. In the first example, the blue square's anchor is set to fill the parent item, but since the margins are set to 8 pixels, the blue square will only fill the green square up to an 8 pixel distance. In the second example, the blue square is anchored on the left anchor line of the green square, while its y-coordinate is set to 8. The third example shows the behavior when anchored on the parent's right anchor line. The fourth example shows that you can also define anchors between items. In this case, blue 1 anchors on its parent's horizontal center, while the blue 2 horizontal center anchor refers to blue 1's horizontal center. The fifth example centers the blue square in the green square, which is equivalent to setting both the horizontal and vertical center accordingly. In the last example, the blue square is centered according to the anchor usage, but when the horizontal center offset is introduced, it gets pushed left for 12 pixels. The second term I've mentioned earlier is margins. The anchoring system also provides these margins and offsets. Margins specify the amount of empty space between an item and an anchor. It can be specified individually or set to the same value for all of them by setting anchors.margins for an item. When creating scalable and feature-rich UIs, the need for dynamic changes, different states, or prompt creation of UI elements is evident. I will talk about the two main items that can satisfy these needs, the loader and the repeater item. The loader is used to dynamically load QML components. These can be loaded from a QML file, which is shown in the first example. A loader item with the ID page loader is created. The mouse area will fill its parent, and clicking on it will set the page loader source property to page1.qml and trigger the loading of that QML file. In the second example, the loader item is set to fill the parent item, and the rectangle component with ID rect is set as the source. Setting the source component property to undefined destroys the currently loaded object, and the resources will be freed, leaving the loader item empty. The repeater item is used to create a large number of similar items. It can instantiate a given number of items or, since it's a view type, display the objects provided by a model. The next chapter will cover the model view delegate concept in more detail, so for now we will leave it at that. In the example, we can see how a grid positioner is filled with 16 squares, because the model property of the repeater item is set to 16. It will create 16 instances of a delegate item that is defined as a rectangle with a randomized color index that will define the color out of the 3 given options in the color array, and a text item that will show the actual cell index. But now let's see how that translates to our temperature gauge. You might remember when I instantiated these 9 gauge items in my grid layout. This is of course a very cumbersome approach given the amount of items. So let's get rid of these and have a look at the repeater. Right now the model property is set to 7, so the repeater will of course instantiate 7 gauge items. So let's quickly run and check, and this is the case. But for now, just for fun, let's change that quickly to 16 and run it again. And as you can see, this is also working just fine. And this is, of course, a way more elegant and maintainable solution compared to instantiating 9 single gauge items in my QML file. But for now, let's continue with the next topic, model view and delegate items. QML, or Qt in general, provides the concept of model view and delegates. Since this is a complex topic, we will only scratch the surface. In general, the model's role consists of containing and handling data and the structure of data. The view is responsible for displaying the data, and a delegate dictates how an item is rendered and encapsulates each unit of data in the model. There are already different views and models available in QML. For example, the list and table view with the corresponding model list model and Q abstract table model. If the provided models don't fit your requirements, you can implement your own model class inheriting from Q abstract item model in C++ and implement the model functionality according to your needs. If you want to know more about this topic, please look for our model view overviews in our online documentation. Let's have another look at the temperature gauge and how this concept is applied to it. At first, we are going to use a grid layout in combination with a model and a delegate. The model property is now defined by an instantiation of a gauge model. So let's have a look at this. The gauge model is a simple list model where each list element consists of a room string, a temperature, and a current temperature. For the sake of simplicity, this example uses a model defined in QML. The best practice is, of course, to create a model object in C++, register it with the QML engine, and use this registered model object in C++. In the gauge implementation, we can see that property aliases were defined that are bound to properties of items inside the gauge item. This way, these properties can be set and reached from outside the gauge item. In our case, this is the temperature value, current temperature text, and room name text. When we head back to our grid layout, we can see when the delegate gauge items are created, the property aliases we've seen a few moments ago are now being set by the properties of each list element. So now one gauge delegate encapsulates one list element of our gauge model. So let's have a look how that turns out. And as you can see, the gauge properties are now set by model data. Now we are going to use a grid view for our gauges and see how it behaves. The width and height of each cell are now set to 200 pixels. Let's run it and we will see that the grid view behaves different than the grid layout. If I resize my window, the grid view will reorganize the position of the gauge items according to the available space. Since the grid view is also flickable, you can then scroll or swipe in order to see every item. At the beginning of this webinar, I mentioned Qt, our pre-built embedded Linux images for different hardware platforms. Here I will use a QBSP made for the Toradex Apalis IMX8. Once downloaded, a QBSP gets installed and integrated automatically into Qt Creator. With the Qt flashing wizard, you're also able to flash your SD card in a convenient fashion. A kit will be created for your board in order to use it in a project and cross-compile your project to the target platform. Once you define the boot to Qt device and set up a TCP/IP connection or USB connection, you should be good to go. So let's have a look at how that works. And once booted, you will be greeted by a Get Started with Boot to Qt welcome screen. Here you are able to configure your USB Ethernet connection or enable and set up your Wi-Fi. Once you have cross-compiled your project in Qt Creator, you are then able to deploy it to the device. So first, let's upload our first row layout example. And as you can see, it scales and works just fine. And now I will quickly switch to the grid layout example and deploy that. And as you can see, in general, this offering can save you a lot of time and pain, since you are able to cycle through iterations and changes rapidly, and you're also able to evaluate your design and UX choices and their performance, especially during the early stages of your development. Now it's time to quickly summarize the topics that were presented. We've seen some fundamental concepts of QML, looked at components and how to componentize your UI, how to use UI elements in combination with positionists, layouts, anchors, and margins, and finally repeater and loader, as well as the concept of model view and delegate to enable a dynamic behavior and user experience. You will be able to create modern, feature-rich, and scalable UIs by using and combining these functionalities provided by Qt. Last but not least, I want to present a brief outlook on what's to expect in the future. Qt has been released 5 years after Windows 3.0. Obviously, technologies, requirements, and UX have evolved quite a bit since that. Creating UIs according to responsive design rules is challenging, and Qt is improving its APIs to tackle these challenges. Beginning with 6.6, Qt will support responsive layouts by introducing a new property, flow alignment, and the align justify mode, which allows the layout to reposition and stretch items if there is free space available. There is also the option of setting a flag called uniform cell size on a layout, which is popular in web design. For example, this flag allows you to easily create a layout with equally sized rows and/or columns. Another new contender is the layout item proxy, which enables you to have multiple layouts where one of them is activated depending on the available screen or window space. These are only some of the examples of new features. If you want to know more about this, check the blog post Responsive Layouts in Qt. The link is shown on the bottom of this slide. Also, please feel free to comment and give feedback and more input on what you want to see and what you are missing with regards to responsive layouts. Thank you for attending this webinar or watching the video on demand. I hope it gave you a good overview and you gained new insights. If you have any questions or need directions, please feel free to ask in the chat or in the comment section. Reach out to us directly or engage with our community in the Qt forums. Thank you for your attention and have a nice day.